everyone. Welcome to SECOORA's webinar series, Coastal Observing in Your Community. Thank you for sharing your lunch hour with us. My name is Abby Wakely, SECOORA's Communications Director, and I will be facilitating and moderating the webinar. SECOORA is hosting this webinar series to discuss, highlight, and raise awareness about coastal ocean observing activities in the Southeast U.S. SECOORA is the regional coastal ocean observing system for North Carolina, South Carolina, Georgia, and Florida. We are one of 11 that make up the NOAA-led U.S. Integrated Ocean Observing System. Our mission is to sustain, promote observations that help keep you safe. This is a quick snapshot of the technology we support to complete our mission. Here are a few SECOORA opportunities and news. It is still hurricane season. We have a hurricane data research page. This allows for quick access to hurricane data. We are hosting a 4-part webinar series on using sea level rise data in the classroom. The first webinar is October 15th at noon. This link brings you to more information. SECOORA and many partners are hosting a Drone in the Coastal Zone workshop for the Southeast and Caribbean next year. Please save the date. And lastly, our 2020 annual meeting will be held in St. Petersburg, Florida on May 18th and 19th. Information will be posted to the SECOORA website as it becomes available. All right, let's get to the reason you're all here, the webinar. All participants will be in listen-only mode. You are encouraged to type questions for the presenter or technical questions for me in the bottom right-hand chat box. I will respond to them directly or post the questions to our presenter after his presentation. We are recording this webinar today and will be posting the recording on the SECOORA website. We are very excited to welcome Dr. James Morris, Jr. He will be presenting announcing OceanReports, a web-based tool to inform planning and permitting in coastal and ocean waters. Dr. James Morris is a marine ecologist with NOAA's National Ocean Service National Center for Coastal Ocean Science. His research focuses on aquaculture, environmental interactions, siting, and sustainability. Dr. Morris founded the Coastal Aquaculture Siting and Sustainability Research Program that develops tools and provides services for coastal managers. His multidisciplinary team is presently leading over 50 research projects around the U.S. on spatial planning for nearshore and offshore aquaculture and assessments of environmental interactions. You can read the full bio on the SECOORA website. Dr. Morris, thank you so much for joining us. I'm going to go ahead and promote you to presenter so you can share your screen. And I should be passing presenter privileges over now.
Okay, thank you, Abby. Can you hear me okay?
I can hear you just fine.
All right, wonderful. Look, thanks so much to SECOORA for hosting this webinar and inviting me to speak with you today. This is an exciting opportunity to be able to share some information about OceanReports. We're now about in month 6 of rolling out OceanReports. We've been getting around the country quite a bit and doing yes.
I'm not seeing your screen.
Let's see here.
It should be the little arrow on the bottom. There we go.
Okay, how's that?
Perfect. And once you, perfect.
Okay, sorry about that. So we're excited that this is part of our rollout for OceanReports. I'd like to first start by telling you about our team, and we have a blend of federal scientists and contract scientists that have worked with us on this project. This project has been led primarily by the NOAA Office of Coastal Management and the Bureau of Oceans Energy Management and NCOS. So myself and Dave Stein with OCM and Christine Taylor with BOEM, along with a host of FTE and contract support staff from, I think, 5 or 6 different contract companies that have provided service to NOAA throughout this development process. So I want to make sure that I communicate with you that there's been a lot of people, a very large team that has been working behind the scenes. We work to recruit some of the brightest computer programmers and marine spatial scientists around the nation on this project, and we're extremely proud of this blended workforce that has worked with us to build this application. So the vision for OceanReports originated out of the MarineCadastre team at the Office of Coastal Management. It was visioned about, I guess, more than 3 or 4 years ago, that there was an opportunity to build upon the MarineCadastre data and data center there, and to be able to build a smart web application that would provide some on-the-fly analytics into the conversation with an aquaculture perspective. In our aquaculture program in the Ocean Service, we work to bring marine spatial science services to the nation's coastal managers and better understand environmental impacts. And we knew that we needed a more intelligent way to go about marine spatial science and marine spatial planning when it came to aquaculture being a new ocean industry. And so there had been some vision that that in terms of how do we bring that smart web application to the forefront. And we came to the conversation and really brought some energy and some resources, and we talked about the need that aquaculture has, as well as other ocean industries. And what we collectively envisioned was that we wanted to build a web application in which you could go and you could pull up a map, a box anywhere in the U.S., in the entire U.S. ocean, then within a second obtain a comprehensive spatial analysis with reports and infographics and the ability to interact with the map viewer, be able to really explore that ocean neighborhood from your laptop or desktop computer. We wanted to be able to do that anywhere in the U.S. easy, and we knew that it needed to be fast in order to be impactful. We set out to do that. We built the team, we pulled together the resources, and we began asking questions about what could be done. And here are some quick facts before we get to the demonstration. So this is a BOEM NOAA partnership. It's part of the MarineCadastre.gov toolbox. If you're not familiar with MarineCadastre, I'm sure that most of you are. I encourage you to check it out. It's what we think is the largest repository of marine spatial data maybe on the planet. There's obviously linkages with SECOORA and I use data in MarineCadastre. It's an amazing resource. Knowing that that was in hand, we really began to think about how can we automate spatial analyses with all of that data and create unique reports that can help with the permitting process, can help with coastal development, help with conservation and all those kind of things. MarineCadastre, we looked at over 100 data sets in MarineCadastre and said those are the ones that we want to pull into OceanReports to design easy to interpret infographics, charts, graphs, and graphics. We built this tool with the user in mind. And in our aquaculture program, we are sitting knee to knee with coastal managers around the nation. In the EPA, the Army Corps of Engineers, we work with the Coast Guard, we work with the Department of Defense, we work with various different types of coastal managers in pretty much all the state agencies that would be dealing with coastal development from aquaculture. And we ask them questions about what do they need? What do they need to know about the coastal ocean when it comes to having those permitted discussions? And so we brought that into the development process, thinking like managers that are managing aquaculture, but also that are managing shipping lanes or wind farm placements, siting, or any commercial fishing, the spatial. We try to think as those industries, consultants, planners, policymakers, and scientists. We work to design this on commercial and open source software, and we constantly were pushing to make sure that this was a lightning fast application. So what are the benefits of this? We believe that OceanReports can increase regulatory efficiency and transparency. There's a whole lot of discussion right now in all of our workspaces about regulatory efficiency and how can we streamline, how can we make government processes more efficient, how can we help coastal economies grow and sustain working waterfronts and all those kind of things. We believe Ocean Reports can help with that. We know that Ocean Reports can help increase transparency, which can help with conservation missions by better understanding ocean neighborhoods. To do these things, industry and NGOs and government can be better informed through the permitting and coastal development planning process. Ocean Reports can save time and money because of the ability to automate spatial analytics for whatever question that you may have. And as a result, we can see a decrease in the number of permitting false starts, for example. We'd like to think of Ocean Reports as essentially Zillow for the ocean. Many of you have likely used Zillow before in terms of looking around your home neighborhood, thinking about how far that home might be away from schools or how close it is to the interstate and those kind of things. Ocean Reports is essentially an application like that, where instead of putting in a zip code, you're able to go to a map and draw a box around an ocean space. And you're able to get an analysis of that ocean neighborhood. And we are thinking about ocean spaces as neighborhoods. And this tool allows us to visualize and understand all the activities that are happening within that ocean neighborhood. So how do we pull it off? I'm going to show you a little bit of the architecture behind the scenes. We're very fortunate to have really skilled folks that have worked to build this. We're using the Microsoft Azure Cloud. We have various web services and the Postgres with PostGIS and SQL Server technology here. It gives you, if you're what your skill level is with these web applications and such, this is the general architecture. We have our technology front end and back end. Over 11 applications were used to build Ocean Reports, and you can see some of these were taken off. Most of these were taken off the shelf here and are used as part of that technology stack. These numbers need to be updated a little bit. They're a couple months old, but I wanted to share them with you. We're constantly working to innovate Ocean Reports, so the numbers change on us. But right now, we're displaying around 80 infographics. That requires us to do about 100 queries over about 157 vector and raster data layers, and all that is happening in real time. Return time varies depending on your internet connection, but we're talking seconds, and generally we're talking around less than a second or around 1 second for an average query time. So this thing is fast. We pushed our developers really hard to work on the speed problem and spend a lot of resources making sure that folks that would not get frustrated by the spinning dial when you go to run a report. So with that, we'll go ahead and go into the live demonstration, kind of walk you through Ocean Report works. So I just want to do a check. Abby, can you see the screen, the Ocean Report screen really well?
Yes, I can.
All right, very good. So to navigate to Ocean Reports, you can easily Google Ocean Reports, all one word, and it'll be the first link in Google. That sometimes can be easier than navigating through the direct web address. You can navigate to it if you go to MarineCadastre.gov and click on the Ocean Reports link as well, because it is a MarineCadastre, one of the MarineCadastre tools. So this is the home page for Ocean Reports. The general idea of this is that we want it to be extremely user-friendly, and so you can look at spatial analyses for the coastal ocean 2 different ways here. You can draw a custom area in the ocean, or you can view quick reports. To view quick reports, you're able to scroll down and choose quick reports by location or by title, while these are essentially canned reports for any specific location or national park or anything like that. So that you would just type in the name that you want to find the report. A more fun way is, of course, to go and to draw your own box. So you can draw on a custom area. You accept the terms, which do not using this for navigation and those kind of things. And then you can scroll to anywhere in the coastal ocean, and you can draw a box around any particular ocean neighborhood. So we're going to click on draw, and we're going to go here off in the northern Gulf of Mexico off of Louisiana, a real interesting part of our coastal ocean. Just want to use this spot to demonstrate the tool. So here we have drawn a box, and around a second or so, we have a customized oceanographic spatial analysis for this ocean neighborhood. So we can zoom out on the map viewer here on the right-hand side to orient you. We have our reports here on the left-hand side. So we have general information, we have energy and minerals, natural resources and conservation, oceanographic and biophysical, transportation and infrastructure, and we have information about the economics of that ocean space. For any particular infographic, we can turn on and off the data on the map viewer by clicking on the data layers tab, and we can turn that data on, and you can see it pop up here on the map. You can then, of course, zoom in and out in that ocean neighborhood and look at how that data is displayed on the map and how it relates. Turn on multiple data layers at a time, of course, and you can look at the interactions of those data layers and adjust those. Down here on the bottom right, we have the ability to turn off all the layers, and we have the ability also to navigate sort of in a fast way to just turning on the specific data layers we want to look at. So, and then we can clear them off. We can also change our base maps, and so we can use different maps that may have different color palettes that correspond to whatever we want to look at. So I want to share with you the reports that you get instantaneously now through OceanReports. So for this ocean space here off the coast in the northern Gulf of Mexico, that we just drew a box that was approximately 1,000 square miles. Here are the depth and elevation of that ocean space. So in this ocean space, the depth goes down to around 1,400 meters and up to around 31 meters of depth. Here are the nearest cities that are close by that ocean space. We have the federal and state and county jurisdictions, so I can turn those on and I can see exactly that this ocean space is located completely within federal waters. If I were to go, for example, and draw a box that included both federal and state waters, we would see that this would change. And here we have the graphic changes and shows the state of Louisiana waters. About 3.6% of the space that we drew is actually in state waters. We can also click on the information button throughout the infographics to learn more information, to get the legend for colors that might be in the infographics and such. That ocean space that we just drew is within the Congressional District 1, and also provides state and House district information. So thinking if you are a stakeholder, if you are someone from industry, OceanReports can tell you exactly what state and congressional district that ocean neighborhood falls within. Here are federal statutes that govern that ocean space. You can click on each one of those, and those will take you to learn more information about the federal statutes that you should be aware of that are relevant to that ocean space. And then we have information about Native American lands, and we have the specific reservations and distance to miles for that ocean space. So that's our general information report. We also have a report next on energy and minerals. We have information about the wind resource potential of that ocean space. This is being pulled from an energy wind resource model. Here you can see that if that ocean space was fully developed with wind energy, that there could be almost around 700,000 homes that could be supplied with energy. Interestingly, we can tell from the infographic though that this is a fair area. It's not an outstanding or even excellent. It's more of a fair rating in terms of the wind energy potential there in the northern Gulf of Mexico. This area is not located within a wind planning area. It's not located within any wind energy leases. Of course, it is located within very rich oil and gas resources. So here you see that there are 12 geologic plays for oil and gas that are located within those. Click on to show all of those plays, and we're able to show those on the map as well. And they would show us exactly where those exist there in the Gulf of Mexico. We can scroll on down and we see that we are located within the central Gulf of Mexico oil and gas planning area. There are a number of oil and gas leases within this ocean space. So if I was curious to say, okay, where are those located close to the box that I just drew, we could turn on the oil and gas leases And here you see there's a number of those that are located within that ocean space that we just drew. I hope that you're beginning to sort of understand the value of ocean reports and how we're really working to increase your ocean IQ, if you will, as we go here. We have information about the electric power facilities near the coast that you can turn on and off. We have information about block areas for sand resources, federal sand and gravel lease information. So there aren't any within the box that we drew. So let's see if there's any within the neighborhood. Goes on, and we see that there are some gravel and sand leases that are within not within more than 5 nautical miles of that ocean space. We have information on beach renourishment projects and sediment, and then ocean disposal sites. So it looks like there's 5 ocean disposal sites within 10 nautical miles of that spot, and I can turn those on and check those out. If I want to learn more information about those, I can click on the links here provided in the information button and look at what type of ocean disposal site that is displayed in the report. Moving on to natural resources. Obviously, being in NOAA, we took this one very serious, and we wanted to make sure that we're displaying the best information that we could about things like endangered species, critical habitat designations. We have information about highly migratory species that transit this area. We have, for example, the shark species and the life stages that they are found. They could be found within this ocean space, as well as fish species. So here you see we have big-eyed tuna juveniles, blue marlin, adult and juveniles, bluefin tuna, etc. We also are able to map out biological important areas. I happen to know that there is not one located close to the coast of Louisiana there, but if I turn on the layers and look in and zoom out in the Gulf of Mexico, I see that we do have some BIAs, whale biological important areas just to the east of that ocean space. Very important to know in terms of that ocean neighborhood. Moving on down, we have information about birds. We do map protected areas. So here we have 2 protected areas within 15 miles of that ocean space, and I can turn those on and I can look at what they are. They're the Delta National Wildlife Refuge and another wildlife management area. Artificial reefs are quite interesting to map as well. We're pulling the artificial reef data. There's 6 artificial reefs within that ocean space, and here they are on the map. Again, being able to zoom in and out and be able to really explore that ocean neighborhood. What are corals, coral habitat suitability, and those kind of things. Our next report is oceanography. The idea of being able to build an on-demand oceanographic analysis that brings in climatological data about ocean current, ocean wind and wave climates, really a very high priority for us. I wanted to get that right. We're very excited to be able to show you that within this ocean space, we're able to produce the information about current, speed, and direction. So these are provided in roses. So this will be a current rose. And you can look at by month in terms of how that current velocity changes. So that rose gives you magnitude and direction. We're also able to look at wave height, period, and direction, also in a rose, with how it changes over time. And then we have wind as well. Also map things like tropical cyclones. So this looks at the frequency of hurricanes. And here you see that we have hurricane frequency for that ocean space. That would give you the number of times that a storm passes that ocean space, can be derived from the graph here, as well as by looking at the map. Information about sea surface height, water temperature, salinity. We're able to use data sets that allow us to drill down into the water column and display that. So here we have the salinity at depth, and we have temperature at depth that's been modeled for that ocean space. For example, if we want to turn on the sea surface temperature layers and things like that, we can look at the sampling stations for the model temperature that we are displaying there. And that tells us a whole lot about the ocean chemistry of that ocean space, including the nutrients like nitrates, phosphates, aragonite. We have information about light and light attenuation through the water. The next one is transportation and infrastructure. This is basically where all of our industry data is located. Information about vessel traffic Here we can turn on and look at how vessels are moving around that ocean space. Here you can see the port of New Orleans and the traffic going up the Mississippi River. It's a really cool and interesting sort of ocean economy at many different levels there in the Northern Gulf of Mexico that really have bright colors and such. With this, we can discriminate what kind of vessel traffic we want to look at. For example, here are the cargo vessels. Here are the fishing vessels. Here are the passenger vessels, pleasure crafts that's going through that space, tankers, and tug and tow. And of course, if we wanted to just to display sailing and passenger vessels, we can discriminate those. And so this creates a really cool AIS tool in terms of looking at vessel traffic in the U.S. oceans. We can also look at vessel routing. We can look at designated anchorage areas around ports. There should be some there around this ocean space. We can turn those on and check those out. Here you see, in fact, we do have some ocean anchorage areas there. We also have pilot boarding areas. We map our ports. We look at where maintained channels are. We have military data. This was an interesting conversations with the military in terms of the data to make public here. And we're able to turn those on and look at military areas around the Northern Gulf. We, in terms of danger and restricted zones. So here we have a danger and restricted zone to the east of us there. We do have unexploited ordnance areas within this as well. There's 2 within 20 nautical miles, and I've turned all those on for the Northern Gulf. You can see those displaying there. Known shipwrecks and obstruction. One of my most favorite layers to turn on to better understand an ocean neighborhood is a seafloor infrastructure. And here in the Gulf of Mexico, we have significant seafloor infrastructure. So we can turn on our cables and look at undersea cables and look at where those are and where they are going. We also can turn on cable areas and pipelines. When we turn on pipelines, here you can see that that the seafloor infrastructure really comes out. You can see all the different types of pipelines and cables that are around that ocean space. Looking here at our box that we just drew, we can zoom on in and we have higher resolution data that as you go into the app, further into the map, that shows you exactly where that infrastructure is, and you can then reposition your drawn area if you want to as it relates to your objective for using OceanReports. I have information about other industries here that you can map, things like the oil and gas platforms in the region. That's always an interesting thing to turn on, and as we turn those on, and you can see those oil and gas platforms light up there. If we wanted to look at those, for example, independent of the pipelines, we can turn everything off and then turn on gas platforms. Zoom out to give you more of a perspective there. You can see the oil and gas platforms are many in the Gulf, and you can zoom in and out to look at where they are located. And in fact, we have 22 active oil and gas platforms within that ocean neighborhood that we just drew. Then lastly, we have information about the economy. We wanted to provide some baseline information about marine-dependent jobs within that ocean space and the surrounding neighborhood. We have information about the GDP. We generally map the 3 closest states. So here we have Alabama, Louisiana, and Mississippi. Here you can see that the offshore mineral extraction industry is large with shipbuilding, tourism, transportation, marine construction are the primary sectors of the economy there. We have census statistics, commercial fishing landings. This is pulling in the federal fisheries data, looking at the fish species, the annual weights, revenue, and the price per pound. And then we also have mean fishing economic value. So this has been sort of a slow walk through the OceanReports app. Before we conclude, I want to share with you what you can do with it. So we have up here in the menu, you click on the menu, we have the About page where you can learn more about the OceanReports app and how it was developed. We have information here about how you can print the report. So depending on your objective, if you are a coastal manager and you're going to a meeting, if you're a congressional aide, or if you're a scientist or an industry and you want to go work with regulators, you're able to create these custom reports that provide the specific information that you want to pull out the report. So you can click on the report type on the bottom, choose the industry that's relevant, choose the infographics, and turn on and off things that you want to bring to your meeting or to the analysis. And then you can, of course, print it. You're also able to click on share, and you're able to share a link. And if you copy that link and send it to me, I will be looking at the same exact analysis that you just ran with OceanReports. So it makes it highly shareable among different users. And then lastly, you're probably asking, show me the data. Where's the data? You click on the metadata tab, and for every data that is in OceanReports and analyzed in OceanReports, you can click on the data set. It takes you to to download it. And this is all sort of serviced through MarineCadastre, and it also gives you the provider. When you click on that data set name, you're then taken to the metadata where you can read about the data set. You can look at the interpretation of the data. You can look at the methods of how the data was collected, the age of it, who the owners are, and really help you understand how the data were analyzed, where they came from, and whether or not you believe the data or if you question the data. It's very hard to be able to bring this this tool in a way that is highly authoritative in terms of having very trusted and vetted data sets. We spent a whole lot of time discussing and debating the way that we analyze the information and data, how we display it. I should tell you that OceanReports is very much a work in progress. We continue to work on it and change it, and it will evolve over time as we get feedback on how folks are using it and how they're particularly using it in conservation and the regulatory environments and in science. I'll stop there. I'm sure that there's going to be a significant amount of questions and discussions. I believe that my colleague Dave Stein from OCM is on the phone that can also help answer some of these questions. And again, Abby, we'll turn it back over to you. Thank you so much.
Great. Thanks so much, Dr. Morris. Wonderful presentation, and OceanReports really is the Zillow for the ocean. What a great analogy. We did have a couple questions come in while you were presenting. If you all have any questions, please type them in the bottom right-hand chat box, and I'll ask Dr. Morris. So the first one is from Kent. For the oil and gas lease and platforms, can you pull up the actual platforms and the OCS block numbers? OCS area and blocks are the BOEM oil and gas designations.
Right. We did not turn on the way to identify the individual platforms in the data set, but of course one way that you can get to that is by going in and downloading the data and bring it into your own GIS.
Perfect, thank you. And then another question from Linda, how often are the raster data layers updated with the most recent information? And I believe you answered her second question. Is there a way to access the metadata associated with the raster data?
Right. So the how often is the data updated is the #1 most asked question about OceanReports, I believe. And the answer is it's updated as often as data are updated in MarineCadastre. And MarineCadastre is updated on a schedule, on a maintenance plan, a data maintenance plan. And every data set has a different requirement in terms of a refresh rate. So if you imagine the volume of data and how much work that we're doing, that the Ocean Service and BOEM and NOAA are working to update those data sets. Some of this, is user demand. We know that there's some data sets that require a higher refresh rate than others. Some of these data sets are long-term climatological data sets. Looking at a 30-year climatology, how often do you update that? So it really depends on the data. And I would ask you to be the most critical user of the data. When you look at how something is displayed on a map, you should want to understand where the data is coming from, how was it analyzed or how was it developed, and ask yourself, is the data relevant to the question that I'm asking? And that is ultimately on the user's responsibility.
Great, thank you. And then another question, is the data downloadable? But I believe it's downloadable from the metadata tab. Is that correct? Awesome. And then from Marie, have you considered adding satellite products to your report?
So we have, as you can imagine, a long list of additional data products. We worked hard to get the baseline done. What you see here is a filtered list of reports and data that we were able to pull together for the first release. Imagine, as we have worked to communicate and roll out this this application, we're getting a lot of input. We're getting a lot of folks say, "Hey, use my data," or "Here, this is a good type of data that should be in there," and all that kind of stuff. We're working to prioritize opportunities for adding data. We need to give priority to things that can have big impacts, that is very mission relevant to BOEM and NOAA stewardship missions and economic commerce missions. I would ask, like satellite data, for example, and there's many different types of opportunities there. I would say that if you have ideas about data, please reach out to us. Here are our email addresses there for BOEM, OCM, and NCOS. Send us your ideas, and we have a parking lot, if you will, of ideas that we are sorting through and trying to prioritize those, and we'd love to hear from you.
Great, thanks so much. And I will say, Dave, you're on mute. He stated in the question, some of the oceanography data is satellite derived, aragonite, all of the lights, and turbidity. If you guys have any more questions, please type them in the chat box or the Q&A. As a reminder, everyone's in listen-only mode. We have a big group. All right, no questions have come in. This is your chance. We'll give it one more minute. All right, so from Deborah, what are the next data sets you hope to add?
We are working on a number of them right now. One of them is, because in our program office we have a large harmful algal bloom science program. We really want to get HABs included, especially for the Gulf of Mexico. So we have a pretty cool HABs data set that we've stitched together for the entire Gulf of Mexico that looks at the frequency of blooms over time. And we're going through the review process for that data set now, and it will appear in the oceanography report. You'll be able to zoom in and see what has been the frequency of HABs blooms, and you'll also be able to link that to the relative toxicity of those blooms, so to speak, in terms of cells per milliliter of water. So it gives you the bloom intensity as it relates to fish kills, potentially other ocean, effects that could have on ocean industries like aquaculture and those kind of things. So that's one of the data sets that we're working on right now, and there's a list of others as well.
Great, and then we have Dave chiming in. He said more granular nutrients. Most of those data are from Esri's EMU. We're working to incorporate monthly averages at depth. And then Matt has followed up, would the HAB data be the HAB SOS data?
The HABs data comes from multiple sources.
Gotcha. And then we have another question from Jennifer Dorton. Will you be providing other online tutorials in the future?
Likely. We're working on some tutorial videos and those kind of things, and we're we hope that this application is pretty simple. That there's not a whole lot of, we've sort of built it to be really user friendly. We're still working on that. We have some modifications that we want to make and are working to make as we speak. But we really need user feedback. So we need user stories. So if you're involved in a project, whether it be science, regulatory, conservation, whatever, and you're using Ocean Reports and you've increased your ocean IQ by being able to use Ocean Reports and better understanding any ocean neighborhoods, we'd love to hear those stories. And particularly if you have user feedback on how it could be improved, we'd love to hear from you on that. But we are thinking about tutorials, but we're at this point, we're really interested in your feedback on how you're using it.
Thanks. And we have another question that's kind of similar. Do you track your users? And if you do, how do you track them?
So obviously government applications like this have challenges when it comes to tracking users. There's all kinds of rules about the kind of information that the government can take because of privacy issues. So we get some information about hits on the website, how long people are on there. We're not able to really track at a high level of detail, and that's kind of a challenge for us that we're working through. I do see a question here about how far inshore do the data extend, and that's a great question. We have been working to, we didn't clip, some of this data obviously extends into state waters, and we purposely did not clip that data out. We want to be able to bring it to include the whole entire U.S. ocean, focus our energy and resources largely in federal waters.
Great, thank you. And that was asked twice, so important question. And then we have another question from Linda. Is there a way to tell what type of satellite imagery is used, Landsat or QuickBird?
That would be in the metadata.
Great, thank you. And then Dr. Morris, can we have these slides to download and share with the participants?
Yeah, absolutely. I'll provide you a PDF of the slides.
Perfect. And then if there's any more questions, please type them in. We still have 15 minutes. We're getting a lot of kudos on the simplicity of the metadata access, so good job, team.
There's a question from Kathy that I'd like to go back up to. It says, would this provide changes after a hurricane or comparisons thereof such as Harvey? That's a great question. And Dave may want to comment on this as well. We have been thinking about the temporal aspect. I hope that your sort of mind is blown a little bit about the power of this application. Think about what we had before this. You would have to go into a portal, a data portal, if you will, like MarineCadastre or in the regional ocean portals, and you have to sort of pick from categories of data, bring it into your GIS or show it on a map viewer. What this does is it automates and provides an analytical report, an analytical analysis, if you will, of that ocean neighborhood. Think about where this can go in the future. The ability to do higher level analytics, such as looking at temporal changes in the data, and being able to do that somewhat in real time are all possibilities, but it's depending on resources and expertise. But right now we don't have the ability to really look at sort of that, hurricane changes or anything like that unless we're updating the data. But we do have a temporal aspect built into some of the infographics, like current, for example, where we've played around with tools like slider bars that look at how current changes or wind changes over the course of a year. But that's a great question, and we all need to be more creative in thinking about how we can use temporal changes to better understand ocean neighborhoods.
Great, thank you so much. From Terry, are current aquaculture leases, in parentheses, footprints included from any state?
Yeah, we do have an aquaculture layer in there. If you go into the transportation and infrastructure, aquaculture infrastructure is included. This is a spatial data set that we developed a few years ago that looks at where, from states primarily, looks at where aquaculture is occurring in the coastal zone, and it shows up on the map.
Great, thank you. And thanks for catching Kathy's question. All right, are there any more questions? Everyone is blown away. All right, we'll give it one more minute and then we can end the presentation. If you have any questions, just please type them in the box. And then Kent stated he highly recommends to add OCS areas and blocks with numbers and platform identification. These are helpful for renewable energy and aquaculture.
Yeah, absolutely. Very good point. While we're waiting for the question, we have been thinking about that and doing that. There are ways to turn on so you can, when you mouse over data on the map viewer, data can pop up and those kind of things. Those are all approaches that we have been working on and thinking about as well, not just for the OCS block data, but for a lot of different types of data in there. For example, the national parks, you can, or marine sanctuaries, or wildlife refuges. Think about how to mouse over those and how to display that data. Is a complexity in the OceanReports engine, so to speak, in terms of how to deal with that in the app. And sometimes we have to sacrifice functionality for speed. But we really appreciate that statement there of knowing that. Dave says to please take a look at the oceanographic data. Our goal over the next couple of years is to incorporate higher resolution climatologies.
Yes, and everybody has their contact information, so please email them feedback. All right, seeing that there's no more questions, I'm going to go ahead and take over and share my screen. One second. Thank you, Dr. Morris, for such a great presentation. If we did not get to your questions, you can either email Dr. Morris. His email is right down here, james.morris@noaa.gov, or you can email communications@SECOORA.org, and we'll ask those questions directly to Dr. Morris. A recording of the webinar along with the PDF of the slides will be on SECOORA.org/webinar-series, and I'll be sure to email everyone once it's available. It usually takes about a week to be posted. Once again, Dr. Morris, thank you so much for the great presentation, and thank you everybody for attending and asking such great questions. It was really active.